Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 1 of lesson number 4, structure of the atom. So when it comes to atom, you might have studied in your previous standards like what exactly are atoms. We know like the meaning of the term atom, it means like it is indivisible, right? So the meaning of the word atom is indivisible. It means we cannot divide it further, right? So here in this lesson, we are going to discuss on the atomic structure, like how exactly the structure of the atom is been, like you can say, arranged and what exactly it is made up of. Okay, now you might be getting an idea by looking at the picture that has been given on screen, which includes electrons, protons, neutrons, nucleus, right? So yes, that are the different parts of atom, by like you can say these are the components by which the atom is made up of. Okay, so we are going to study all of them in detail. So it's not that you will be just studying about what is atom and all. Like there are many different things to study in the lesson. And you know what? The exercise questions which have been given after the lesson are more than 13 questions. So like it will be a good time discussing the question and answers with you. But as you all know, we do that at the end of the lesson, right? So now as this is part 1, I'm going to make you aware about the lesson. I'm going to introduce you the lesson. So it's like when you meet a friend for the first time, you don't know anything about the friend, right? And you just get to know something, some basic information about the friend. And when you meet it twice, the bond is different. When you meet it thrice, the bond is very different. And when you meet it for like 8 to 10 times, the bond becomes very different. So that is the strategy that we need to follow. Okay, so you have to know what is structure of the atom. In this part it will be an introductory part to the lesson, so that you know what exactly you are studying, because I have observed like students don't know what they are studying, and it's like they are just rectifying the concepts, which I don't want any one of you to do. So here we will be discussing on structure of atom in detail. Okay, so I will be letting you know many things, but before I start, I want you all to please give a heading in your book, structure of atom, because there are so many subtopics under it that I'm going to introduce about, that you will have to take a note on. And one more thing I want to add over here, like whatever information that you have on atom, see, it's not that you're studying it for the first time. If any one of you are studying it for the first time, no worries, I'm there to help you out. But if any one of you or anything you know about atom, I want you to just write that in your book, because at the end of the lesson, you will again do the same thing and you will come to know what exactly you have studied in the lesson. Okay, so please write whatever you know about atom. Sorry. I hope everyone is like adding on the information if you have any, because as I said, it will boost your confidence at the end, which is very important. Okay, when I end the lesson, like when I complete teaching you the lesson with exercise and all, you should have a different confidence in yourself that yes, I know this, and like even if I'm not, you can say, not looking at it, you're not going through the exact answer, you will be able to frame your own answer. Now you have to learn that because like you will be moving on to 10th grade now, right? So you have to slowly and steadily learn it. I'm not telling you that you should be knowing it now. You have to like slowly and steadily learn how to write the answers. Okay, and while I explain you or while we discuss exercise, I'll tell you that as like how to write the answers point wise, how to present your paper, everything. Okay, but before that, I hope every one of you are writing whatever has been like known to you. Okay, I'm giving you last 1 minute. Whatever is in your mind should be on paper as well. Okay, so now see, what here in this lesson we are going to study about the structure of the atom, right? So you should be knowing what exactly atomic structure is. So see, atomic structure, it refers to structure of an atom which comprises of a nucleus in the center. Now you have to look at the figure, the diagrammatic representation that has been given. Okay, what it comprises of, it comprises of a nucleus, okay, in the center, in which protons which are positively charged and neutrons which are neutral means it doesn't have any charge, they will be present. So what has been said over here, what is structure of an atom, I'll show you. If you can see the center part, it has nucleus. Can you see? This is how a nucleus looks like. And inside that, we have a proton which has been present, and along with proton, we have neutrons. Now, neutrons doesn't have any charge. Protons have positive charge. Neutrons do not have any charge. They are neutral. So, they are present in the center. Okay. And the negatively charged particles called electrons. Now, can you see the symbol of electron? So this negatively charged particle called electrons, they keep on revolving around the center of the nucleus. But in the center, now so just imagine that I'm drawing the structure of an atom. Okay, so in the center, I'm going to have this is the nucleus, and inside this nucleus I'm going to have positively charged proton, and along with that I'll have neutrons. Now neutrons doesn't have any charge, so we cannot show it, but neutrons and protons will be present in the nucleus of the atom, and the negatively charged particle called electrons. This electrons, they keep on moving around the nucleus, or you can say around the center of the nucleus. Got it? So I just want you all to write this in your book, and even you can draw this figure which has been given over here. Okay, but please be quick with it. We will be even studying on different theories in the lesson, like Dalton's atomic theory, we have Thomson's atomic model, we have Bohr's model, we have Rutherford's model. So we will be studying about in basic today, but like when we proceed with the lesson further, we will discuss them in depth. I'm just introducing my friends from Atom to you, okay? So make sure you know some of the other information about them. I hope everyone is writing the about the structure of an atom. Okay, so I hope every one of you have written about the atomic structure. What exactly it is? Atomic structure refers to structure of an atom comprising a nucleus in the center, in which protons which are positively charged and neutrons which are neutral are present, and the negatively charged particle, they keep on revolving around the center of the nucleus. Negatively charged particle called electron. You have to mention the name, okay? Okay. So see, now when it comes to the history of atomic structure and quantum mechanics, it dates back to the time of Democritus, because Democritus, he was the first one to propose that matter is composed of atom. It means matter is something that occupies space and have mass, right? We have already studied that lesson matter in our surrounding, so you know what is exactly matter. So Democritus was the first man who proposed that like matter is made up of, or matter is composed of atom, and we know that atom is indivisible. It means everything that you have around is a matter, that is occupying space and having mass is a matter, right? So that matter is made up of this tiny indivisible particles called atom, and this was according to Democritus, the statement given by Democritus. Okay, so, the study about the structure of an atom gives us a great insight into the entire class of chemical reactions, bonds, and the physical properties. So, when the structure of atom was, like, you can say, studied in depth, okay, we found out like there were so many chemical reaction, bond formation, physical properties which were needed to be studied further. So the first scientific theory of atomic structure, it was proposed by John Dalton in 1800s. So Democritus just gave a statement that matter is composed of this tiny indivisible particle called atom. Okay, but the scientific theory of this atomic structure, it was proposed by John Dalton in the year in like 1800s. Okay, so I want you to write this about Democritus. Democritus first proposed that matter is composed of atom, and the first scientific theory of atomic structure was proposed by John Dalton in 1800s. I hope every one of you are writing about Democritus and Dalton. Okay, so there is a difference in the work that they have done. Democritus has just proposed that matter is composed of atom, and Dalton, he he was the first person who gave us a theory, atomic theory. Okay, on you can say theory on atomic structure in 1800. So there's a difference between both. Okay. So I hope every one of you are done writing about Dalton and Democritus. Now we need to study. See, now the theory was given by Dalton in 1800s. Okay. Then the advances in atomic structure and quantum mechanics have led to discovery of other fundamental particles as well. So it was not that there's an atom. There were other, you can say, fundamental particles which also existed. So because the atomic structure and the quantum mechanics, they were having like advances, researches were going on, many things were known to the scientists. The discovery of subatomic particles has been the base for many other discoveries and inventions. It means the subatomic particles like electrons, protons, neutrons, they have been a base for many discoveries and inventions. Many of the discoveries and inventions were possible because of this subatomic particles. Now you should be knowing like what exactly, like what is atomic structure in short, if you have to tell. So atomic structure of an element refers to constitution of its nucleus and arrangement of electrons around it, like how exactly the nucleus of that element is and how are the electrons over there. Okay, how the arrangement of electrons are there. So primarily the atomic structure of matter, we know that it is made up of protons, electrons and neutrons, right? We know that any atom can be made up of this three atomic structure: protons, electrons and neutrons, right? So now we already studied that protons and neutrons are present in the nucleus of the at atom, and the electrons keep on revolving around the you can say around the nucleus, right? So here we have one another concept called as atomic number. Now what is atomic number? You might have came through this term before as well, the atomic number of this, atomic number of that. So atomic number of an element, it describes the total number of protons. It means the number of positive charge present in the nucleus of an atom. It represents the atomic number of that element. So if we have to find out the atomic number of element, how are we going to do it? By the number of protons present in the nucleus. Got it? And when it comes to neutral atoms, now neutral atoms are not going to have any you can say charge present in them, right? So why we call them as neutral? Because they have equal number of protons and electrons. That is why we call them as neutral atom. So what is neutral atom? Neutral atoms have equal number of protons and electrons, but atoms may gain or lose electron because they have to become stable, right? So to increase their stability, they need to have certain entity called as ions present on them. Like if you know, we write Na, like Na plus, Cl minus. Okay, there are some positive and negative ions which have been present on certain elements. So why do we have those ions present on elements? That is because the atom keeps on like gaining and losing electron, right? So that is one of the reason why do they have ions on them. Okay, so atoms of different elements have different atomic structure because they contain different numbers of protons and electrons. Now different elements will have different atomic structure. Why like everyone is having different atomic structure? Because they have different number of protons and electrons present in them. Okay, so this is one of the reason for this unique characteristics of different element. Got it? Now we need to study about the atomic model. So as I told you that we will be studying about Dalton's atomic theory. We will be studying about, like, after Dalton we have Rutherford's theory, Bohr's atomic theory, and there's one more theory, I guess, Thomson's model, atomic model as well. So we will study all of them one by one. Okay, you know, go back to 18th century. I know we were not there, even I was not there. Okay, so in 18th and 19th centuries there were many scientists. Okay, what were they doing? They were trying to develop a structure of an atom. They were trying to explain the structure of an atom with the help of atomic model. Now we want everything to become 3D, right? So same way they also wanted that atoms should be like they can have a model and they can explain it how exactly atoms have been made. So they were trying to make certain models, and each of this model had their own merits and demerits and were pivotal to the development of this modern atomic, you can say, model. Okay, so different scientists were coming up with different models trying to explain it in the best way. But as like each of them had certain merits and demerits, because of which like further different types of, you can say, model came into picture. And at the end we finally got our modern atomic model which we use now. Okay, so the most notable contribution to the field of atomic model was given to like scientists such as John Dalton, J.J. Thomson, Ernest Rutherford, and Niels Bohr. So these are four scientists who have, you can say, some notable contribution in this field. Which are the scientists? John Dalton, J.J. Thomson, Ernest Rutherford, and Niels Bohr. These are the different scientists. Okay, so their idea on structure of atom they have been discussed, and like we will be discussing about the ideas of all of the four, like what Dalton did, what Thomson, J.J. Thomson did, like then after that what was the model given by Rutherford, and lastly we have Niels Bohr's atomic model, which has been used today. So as I said that each and every one of them had certain merits and demerits. So because of that the modern atomic model was made. Okay. I hope you all are writing some information. So once you're done with it, like I'll introduce about Dalton's atomic theory. We will like go according to the theory, according to the models that were presented. Now, model was Dalton was the first individual to, you can say, present the atomic model. So we'll study first about Dalton. After Dalton, we had like Thomson's atomic model. After Thomson's atomic model, we got, you can say, Rutherford's atomic model. And after Rutherford's atomic model, based on the demerits of Rutherford's atomic model, the demerits were corrected and like put forth by Neil Bohr, and Bohr's atomic model is the one that we use today. Okay, so just write this information that I gave you, and then we will study about Dalton's atomic theory. Okay, I hope you're done writing about this. Now you need to we need to study about Dalton's atomic theory. So Dalton was an English chemist, and his full name is John Dalton. He suggested that all matter is made up of atoms. What did he suggested? That all matter is made up of atoms which were indivisible and indestructible. Okay? These atoms were, we know that atoms are indivisible, we cannot divide them further. Sorry. And we cannot even destruct them. They are indestructible as well, right? So he also stated that all atoms of an element were exactly the same, but the atoms of different elements, they differ in size and mass. What he stated, all the atoms of an element were exactly the same. The atoms are going to be the same, but the atoms of different elements, they differ in size and mass. So chemical reactions, according to Dalton's atomic theory, it involves a rearrangement of atoms so that they can form products. So the atoms need to be rearranged. Okay. So according to the postulates which have been proposed by Dalton, the atomic structure comprised like the smallest particle comprise the atom. Now we know atom is indivisible and indestructible as well, right? So there are certain postulates of Dalton's atomic theory, and the postulate was every matter is made up of atom, which he stated below like before as well, that every matter that we have around us is made up of atom. This was the first postulate. Then he said that atoms are indivisible and indestructible. He's then after that third postulate was that specific elements have only one type of atoms in them. Like there are only specific elements, not all elements, but few of the elements will have only one type of atoms in them, and each atom is going to have its constant mass that varies from element to element. Okay, so every atom, each atom that we have around us is going to have a constant mass, a weight. So but they are going to vary from one element to another. Okay, and these atoms, they undergo rearrangement during a chemical reaction. So they are going to rearrange themselves during a chemical reaction. And the last postulate that was given by John Dalton was that atoms can neither be created nor be destroyed, but can be transformed from one form to another. Okay, so there are altogether like 6 different postulates of Dalton's atomic theory. I want you all to write that one by one. First, he said that every matter is made up of atom. Then he stated that atom is indivisible and indestructible. Then he stated that specific elements are made up of only one type of atoms in them. Then he said each atom is going to have constant mass, and that is going to vary from element to element, and they are going to undergo rearrangement during a chemical reaction. And the last postulate is atoms can neither be created nor be destroyed, but it can be transformed from one form to another. Got it? So I want you all to write this, but before that, see, now this postulates given by Dalton, this is called as Dalton's atomic theory. It successfully explained the law of chemical reaction, which now we know it as law of conservation of mass and law of constant properties. Like there were different laws which were, you can say, explained successfully by Dalton's atomic theory, but there were certain demerits as well of Dalton's atomic theory, which we will discuss. But before that, I want you to write the postulates in your own words, like whatever you understood. It's not compulsory you have to write the same thing that I said. Whatever you understood, you can write that in your own words, because we are going to study that further, right? Anyhow, I hope everyone is writing in. Okay, so now I'm going to explain you about the demerits of Dalton's atomic theory, and I hope you were able to explain in short at least about the Dalton's atomic theory, right? So now what are the demerits of Dalton's atomic theory? See, now Dalton was not able to explain about the existence of isotopes in his theory. Okay, what he was not able to explain? The existence of isotopes, he was not able to explain that. Secondly, he was not able to explain the structure of that atom properly. Okay, he just gave us the postulates, but he was not able to explain the structure of the atom properly. And later the scientists discovered particles inside the atom, and those particles inside the atom was proof that the atoms, like it was proof that atoms are divisible. Okay, so the discovery of particles inside atom led to better understanding of chemical species, and we call this particles inside the atoms as subatomic particle. Okay, so further, the discovery of subatomic particles was done by J.J. Thomson. So it is known as Thomson's atomic model that we will be studying about. So you can write any two demerits of Dalton's atomic theory. Firstly, he was not able to explain the structure of the atom properly. And secondly, he was not able to explain the isotopes, what exactly isotopes were. So he was not able to explain them as well. So I want you all to please write the demerits of Dalton's atomic theory. There are only two demerits, so please be quick with it. Okay, so now the next thing that we need to study is about Thomson's atomic model. So now I said that Dalton was an English chemist, right? J.J. Thomson, he was again an English chemist, and his full name is Sir Joseph John Thomson. So he has put forth his model describing the atomic structure, and his model came in like early 1900s. Okay, and because of the discovery of this Thomson's atomic model, he was awarded a Nobel Prize for discovering the electron, because Thomson was the one who has like gave us this subatomic particle called as electron, and his work was based on experiment called as cathode ray experiment. What was his work based on? Cathode ray experiment. And the construction of working of the experiment is like he had a cathode ray experiment which was done. Okay, so it was like a tube made up of glass which had two openings. Okay, what was it? Tube made up of glass which had two openings, one for vacuum pump and the other one was for inlet through which a gas is been pumped in. So the one opening is for vacuum pump and the other opening is for like taking the gas in. Okay, so that the gas can be pumped in. And the role of the vacuum pump was to maintain the partial vacuum inside the glass chamber. So after, like, because we have partial vacuum inside the glass chamber, a high voltage power supply was connected to it using electrode, and electrodes are nothing but but includes like cathodes and anodes. Okay, what are electrodes? Cathodes and anodes. They are been fitted inside the glass tube. So that is how it works, and we have an observation as well to it, like, what happened in this cathode ray experiment given by J.J. Thomson. Whenever a high voltage power supply was like, suppose I have a high voltage power supply, when the switch on was on, there were rays which were emerging from the cathode towards the anode. Okay, so we know cathode rays are electrons, right? So this was confirmed by the fluorescent spots on ZNS screen, and these rays were called as cathode rays. So like there were much more observation in Thomson's atomic model, but I don't want to explain you like this way, otherwise like you will find that it is very difficult and all. So I don't want you all to create that thing in your mind. Okay, it's very easy, you will understand that. So always remember one thing, that Thomson was the one who has like given us the subatomic particle called electron, for which he was even awarded a Nobel Prize. And Thomson's atomic model is also called as plum pudding model. Okay, but though Thomson has given us this subatomic particle electron, there was one limitation of Thomson's atomic model as well, because Thomson was not able to explain the stability in an atom. Okay, and like along with stability, he was like further, he was also not able to explain the discoveries of other subatomic particles which were placed in the model, like because there were protons and neutrons as well, right? So he was only able to explain about the electrons, but the rest of the, you can say, subatomic particles were not known to him, and even the stability of the atom was not known to him. So I want you all to write in short about Thomson's atomic model, whatever you have understood. If you miss any point, well, like it's okay, because we are going to study that in detail further. It's just that I'm introducing you to the scientist. Okay, so you're not finding them new. Then we have Rutherford's and Bohr's model. In short, I'll explain you about both of them, and then I'll let you know what exactly like we have in the whole lesson. Okay. Just write about Thomson's atomic model in short. Okay, so I hope you have like written about this as well, about Thomson's atomic theory. Now, next that we have is Rutherford's atomic theory. And like Rutherford, he was a student of J.J. Thomson. Just see how good it is, right? He was just a student of J.J. Thomson. He modified the atomic structure with the discovery of another subatomic particle called nucleus. Okay, so know this thing. Rutherford was the student of J.J. Thomson, and he introduced one new, like he modified some of the atomic structures by with the discovery of another subatomic particle called as nucleus. Okay, and his atomic model is based on alpha ray scattering experiment. His model is based on what? Alta, alpha ray scattering experiment. Okay, so he had used a gold foil in his experiment. Then there are many things that he had used. I'll tell you some of the observations that Rutherford has proposed his like own atomic structure. So like what he said, that the nucleus is at the center where most of the charge and masses are concentrated. Where is the nucleus? Nucleus is at the center where most of the charges and masses are concentrated. Then he even said that atomic structure is spherical in shape. How is the atomic structure? It is spherical in shape. And lastly, he said that electrons revolve around the nucleus in a circular orbit similar to the way planets orbit around the sun. Okay, so these are the three statements which have been given by Rutherford, but know that he had used alpha ray, he had used gold foil for his experiment, and he came up with a new subatomic particle called as nucleus. Okay, and he was the student of Thomson. So just by modifying the atomic structure somehow, he came up with this new subatomic particle called as nucleus. Okay, so I just want you to write this much. The three like observation and conclusion that Rutherford has proposed, that I said, that the nucleus is at the center of an atom and most of them are like charged, most of the charges and masses are concentrated. Secondly, he said that atomic structure is spherical. And thirdly, he concluded that electrons revolve around the nucleus in circular orbit, similar to the way planets revolve around the sun. So these are the observations and conclusion by Rutherford. But again, there are certain limitations to it. But before that, I want you to write about whatever I said, the observations and Okay, now let me tell you the limitations of Rutherford's atomic model. See, if electrons have to revolve around the nucleus, they will spend energy, and that too against the force of attraction from the nucleus, right? So over here, a lot of energy will be spent by the electron, and because of that, they will lose all the energy and will fall into the nucleus. So here, the stability of the atom was not been explained by Rutherford because lot of energy has been spent against the force of attraction, right? Which is wrong, because further the new, like, the stability of the atom will not be proper, right? So that was not, like, Rutherford was not able to explain the stability of the atom. Then the second limitation was like, if electrons continuously revolve around the nucleus, then the type of spectrum expected is continuous spectrum. Okay, but in reality what happened, the spectrum obtained was a line spectrum. Now you won't study, like, you won't know about spectrum now because you have not seen the structure of Rutherford, how exactly the alpha ray passes and all. You have not studied that, right? But know this, that this is a limitation to it, that uh, a continuous spectrum should be observed, but in reality he got a line spectrum. So firstly, the limitation was he was not able to explain the stability of the atomic structure, and second limitation is, like, when electrons continuously revolve around the nucleus, the type of spectrum expected is continuous, but in Rutherford's model, in reality, they got line spectrum. So this is one of the, you can say, limitation of Rutherford, on which who worked on this? Bohr's model worked on this limitations, and then, like, we got a proper atomic model by Neil Bohr. So I want you all to write the limitation of Rutherford's atomic model. I hope you all are writing the limitations of Rutherford's atomic model. Then we have the last model to discuss. I know you might be thinking ki how much, like, we are discussing, but this is what you are going to study in the whole lesson, right? Then, like, after this Thomson's model, there are certain subatomic particles. Now, which are the subatomic particles? It includes protons, neutrons, and electrons. These are some of the subatomic particles which we will be discussing in detail. Then after studying about protons, electrons and neutrons, we will be discussing on the atomic structure of isotopes. Now what are isotopes? Like, you might have studied it before, like what exactly isotopes are. right? So we will be studying about isotopes in detail, and then we have certain atomic structure of elements like about hydrogen, how exactly the structure of hydrogen atom is, how carbon atom is, how oxygen atom is. So these are the things that we are going to study before studying the Bohr's atomic theory. Now Bohr's atomic theory is one of the most accepted theory that we have, right, which even we are using it today. So I'll tell you about Bohr's theory, Bohr's atomic theory, and like subatomic particles and all we will discuss when we study the lesson. Okay. So now see what exactly now Bohr's, the spelling of Bohr's is Bohr apostrophe and then S. Bohr's atomic theory. Okay. So the whole name of Bohr was like Niels Bohr. He has put forth his model of atom in the year 1915. Okay, and remember that this is the most widely used atomic model to describe the atomic structure of an element, which is based on Planck's theory of quantization. Okay, so Niels Bohr was the one, like as I said that we use it now as well. So his model was put forth in the year 1915, and this is one of the most widely used atomic model. Why? Because it is describing the atomic structure of an element properly, and it is also based on Planck's theory of quantization. This is the reason of the acceptance of Bohr's atomic theory. Okay, so now like Dalton gave his postulates, Thomson gave his postulate, then Rutherford also gave his some of the postulates. So like Bohr's atomic theory also have certain postulates. Okay, now what are the postulates? There are altogether like 5 different postulates that have been given by Bohr's atomic theory. Okay, the first postulate given by Niels Bohr was like the electrons inside atoms, they are being placed in discrete orbits, and these discrete orbits are called as stationary orbits. Okay, where are these electrons placed? They have been placed inside at like in discrete orbits, and these discrete orbits are nothing but they are called as stationary orbits. Okay, this is the first postulate. Then the second postulate of Bohr's atomic theory is that the energy level of the shell can be represented via quantum numbers. How can we represent energy level? The energy level of the shell, we can represent it via quantum number. Then the third postulate that we had is like electrons can jump to higher level by absorbing the energy and move to lower energy level by losing or emitting its energy. Okay, what is happening over here? Electrons can jump to higher level by absorbing energy, and they can move to lower energy level by losing or emitting its energy. Okay, then the fourth, there are 6 postulates altogether. Okay, so the fourth postulate given by Bohr was like as long as electrons are going to stay in their own state, like in its own stationary, there will be no absorption or emission. And before this I just said that they move from higher level to lower level. When they are moving to higher level, they are doing it by absorbing the energy, and when they move to lower level, they are like emitting the energy, right? So as they are moving, what is happening? The electrons are going to stay in its own stationary, where there will be no absorption or emission of energy. Okay, after that, electrons, they keep on revolving around the nucleus in this stationary orbits only. So like electrons, they will keep on moving around the stationary orbit, and the energy of stationary orbit will be quantized. Okay, so whatever you remember now about Bohr's atomic theory, but do mention that the atomic structure of element, according to this Bohr's atomic theory, the atomic structure of an element is based on Planck's theory of quantization. This is important, and you should even mention that it is the most widely used atomic model. Okay, so please, I want you all to write the postulate of Bohr's atomic model and some information on it as well, because after that we have some of the limitations to discuss. And then we are almost done with the explanation part. I'll show you the lessons and then I'll end up this part. Okay, please write the details that I just said you about Bohr's atomic theory. Okay, so now it's time to like know the limitations of Bohr's atomic theory. See, Bohr's atomic theory work only for single electron species like hydrogen, helium, lithium, beryllium and all, and that is one of the, you can say, limitation. But in your textbook the limitation of Bohr's atomic theory is not been given, so I won't state that now. Okay, so this is how like you have atomic number, mass number and all to discuss. Okay, so now I'm going to show you the lesson one by one. So we are going to start the lesson by discussing about Dalton and by discussing about atoms and molecules in detail. Okay. After that, after discussing this much, we will be discussing on charged particles and matter. Now like we already are going to study about atoms, about protons, electrons, neutrons and all, right? So we'll be doing that. We'll be doing the same thing. Okay, so we'll discuss about this charged particles in atoms, which are known as ions. Then we will be discussing this activity 4.1. After that, like, we will be discussing on the structure of atoms. So you already have an idea, you have met your friends now, you have a basic idea on them. So when I teach you more about it, you will be like very much, you can say, free, right? Because it's some of the part of it. So now adding the information on it won't be difficult for you. So you'll be studying about structure of an atom in detail. Then we will start with Thomson's model of an atom. Now Thomson's model of an atom, Thomson jo the, he gave us the subatomic particle. He introduced electron to us, right? So Thomson's model is also called as plum pudding model, if you remember, right? Or we can even call it as Christmas puddings. Okay, so we'll discuss about Thomson's model of an atom in detail. We'll discuss who exactly Thomson was and like what was the exact work that he was trying to do. What was like proposed by Thomson. So he was like even as I said that it is also called as plum pudding model, right? So he was like he also compared it to watermelon, like the seeds in watermelons are the electrons, like the black seeds in watermelons are the electrons and the red part is the nucleus and all. So that is how like Thomson was trying to explain his atomic model. Then after Thomson came the Rutherford's model of an atom, where he was using like alpha rays, he was using gold foils, and there were reasons why everything was done, but there were certain limitations with Thomson's model as well as with respect to Rutherford's model, because of which like that theory was not being accepted, right? It you cannot say, and this is the thing that I was telling you, like the limitation that it had, that it should have continuous rays, right? But it had line rays, if you all remember. That was one of the limitation of Rutherford's atomic model. So we will study that in detail and you'll understand it better. Then we will study who exactly Rutherford was, what exactly he was doing, what was the work, like where he has achieved Nobel Prize and all, everything we will discuss. Then Rutherford had some drawbacks. Now drawbacks and limitations are seen. If in exam, if they ask you to write a drawback, it means they are stating limitation. If they are asking limitation, it means they are stating drawback. So you should be aware of these terms, okay? So we will be studying about the drawbacks of Rutherford's model. Then after that, we will be studying about Bohr's model of atom, okay, in detail, where we can see like if you can see the figure of Bohr's atomic model, there are like 4 different shells which have been placed over there. So the 4 shells in an atom are K shell, L shell, M shell and N shell. Now how many electrons K shell can have? It can have only 1 electron. L shell can have 2 electrons. M shell can have not 2 electrons here. K shell will have only 1 shell. L shell will have like 2. M will have 3 and N will have 4. This is the 4th shell that we have, and in the center of the nucleus we have positively charged. In the center we have positively charged atom nucleus which has been present. Okay. Then we'll discuss in detail about who exactly Neil Bohr was. Okay, and what are the books in which he appears and what was the theory he was trying to give. Okay, so we'll study about that. And this is the energy level in an atom. As I said that it can occupy only few amount of energy, like K shell can have only 1 electron, number is equal to 1, N is equal to 1. Then L shell can have N is equal to 2, M is equal to 3. Like there are limitation. K shell can have only 2 electron. Okay, L shell can have 8. Like that way you'll understand it better when we study it in detail. Okay. Then we will study about neutrons in detail, like what exactly neutrons are. So we know neutrons are something that doesn't have any charge. They are neutral, right? They are neither positive nor negative. So we'll discuss about neutrons in detail. Then we will discuss on like how are electrons distributed in different orbits. Okay. So as I said, K shell can have 8 electrons, L can have 18, then M can have 18, like that way. So we'll study how electrons are been distributed in different orbits. After that, we will discuss in detail about valency as well. Now valency is very important. You should be knowing what exactly valency is. So we will be discussing about valency in detail as well, what exactly valency is. And after that, like, see in detail valency. Why? Because valency is an important concept which, like, you should be knowing now, because in 10th you will be calculating the valency, and even here you will be told to calculate valency. So there will be certain numerical kind of thing for you as well in the lesson. So make sure you're focusing and understanding the concepts. Okay, so after, like, as you know that the electrons gain or lose electron, because of which they get that ions on them, +1 +2, like Na plus Cl minus. So these ions are like nothing but they are the valency of that atom. So we'll discuss them in detail as well. After that, here we have a table where the name of the element, symbol, the atomic number, the number of protons, neutrons, electrons have been given, and how they are been distributed in all the shells, K shell, L shell, M and N shell. That has been given, and along with that the valency has also been stated. So we'll be discussing about all of them, and it has been given with respect to 18 elements, right? So we'll study that in detail. I hope you all having a glance through it. It's just for your basic understanding. After this, like, we will be discussing about atomic mass, like atomic number and mass number in detail, what exactly they are. Okay, after this atomic number we will discuss about mass number in detail, like what exactly mass number is. And then after mass number we'll discuss about isotopes, what are isotopes in detail. Then after isotopes we'll be discussing, like, see, you will have to calculate that as well. Now for many of them, isolate you can say isotopes are been missed. They have been cancelled from exam point of view, but for some of them it's there, right? So we'll do that. And then we have application to discuss in detail, so we'll discuss the application as well. Okay, like where exactly isotopes, you can say, are being used. So we'll do the application. Then we will be discussing about isobars in detail, what exactly isobars are, along with few examples. And then we have the summary discussion for the lesson, like what exactly we have discussed so far in the lesson. We will do that as well, okay, in detail. And then we have some of the exercise questions to discuss as well. So I'm showing you all the exercise questions one by one. I want each one of you to please go through them properly. So altogether, I guess we have 15 or 16 questions that we will be discussing at the end. So like the questions will be mostly on all the, you can say, models of atomic theory. Okay. So I hope every one of you are going through the questions. I hope everyone is going through the question. Now the questions are very direct. You will be able to answer them so easily, right? So here also the questions are so direct, like you need to explain with example the atomic number, mass number, isotopes and isobars. Now isobars are the last topic that we will be discussing, right? And then we need to give two uses of isotopes. So this question can be for like 8 marks as well. It depends upon the marks for which you get the questions for. Okay, it depends upon the, you can say, paper pattern that you have. So if you can see here, like this kind of, you can say, numericals you can get. So we have more than 14 questions actually. You can see. I thought there are only 14. So this is how we will be discussing the all the 19 questions at the end, and like we will be learning the whole lesson structure of atom. And I hope whatever we discussed today in this part of the lesson you're very much clear with it. Now the rest of the part which has been left, like I'll be starting with the exact lesson for this structure of atom in the next part, and I want each one of you to revise like whatever notes you have taken. Okay, please do revise them all in detail. So now like I'll end up this part and I'll be starting with the rest of the part for the lesson in the next part. Thank you everyone.